And so this is a Plinko triangle. I'm not sure if you've ever played Plinko, but I know I never actually played Plinko, but I'm told it's lots of fun. Now, this is the PHET simulation of Plinko, and you can actually use it to study probability and something called Pascal's triangle, which is what we're interested for the next couple of days. Now, you can use these sliders to adjust the number of rows that you have, and then what happens is when you press start, you can drop a ball. Now, you can adjust the probability, but the way it's set up right now, there's a 50% probability that the ball will go right and a 50% probability that the ball will go left. And you can let a lot of them go at the same time if you want as well. Now, what I want you to do is to actually count the number of possible paths there are to each peg. And then you'll be filling it in on the fill in the blank form just below. So, for example, the number of paths to the top peg, well, there's really only one. The number of paths to the first peg in the second row, well, really there's only one path to that peg as well. It's if the ball lands on the top peg and then goes to the left, it's going to get there. So how many paths are there to this, the second peg and the third row? Well, I'm going to do a little bit of counting here, and so one possibility is that the ball could go to the left to start with, and then it could go to the right. And so there's one possible path, left and then right. Now, it's also possible that the ball could go right first and then left. And so right first and then left is another possibility. And so I see I have two paths to get to the second peg in the third row. And so I'm just going to fill in everything I know into this. I know there's one path to that peg, one to that peg when you go left, one to that peg when you go right. And there's only one path to this first peg. You have to go left, left, left. There's no other choice. And we just saw that there are two paths to this peg, so I'm going to put in a 2 there. Now, complete this triangle, and so you might be able to use some of the counting you've already done to fill in the rest of it. So for example, when I'm getting to this peg right here, well, I could go left, 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 right. That would be one path. I know I have two paths to this, and so getting to there and then going left again would be two more additional paths, so this one would be a 3. There would be 3 paths to this peg.